Innovative packaging for the detection of fresh meat quality and prediction of shelf life. 3 European associations, 2 SMEs, and 3 research centers are involved in this project. Meat is a very fragile product, and any error in meat processing, packaging, distribution, or at the point of sale will potentially affect its quality. Failure to detect a pathogen may have a dreadful effect on consumers' perception and a negative impact on the industry. These problems are important to the meat industry since the freshness of the product is a quality attribute related to the final selling price. The aim of the TOXDTECT project is to develop an intelligent packaging solution for fresh bovine meat products. The proposed system will consist of a passive array of sensors easily embedded within the package at low cost via printing. An external reader will power the sensors and will correlate the different parameters measured in the headspace in order to determine the real state and properties of the meat. The system will consist of an array of passive sensors embedded in the film of the package that will measure the presence and concentration of different volatile organic compounds, or VOCs, highly representative of the quality of the meat. The external reading device will power the sensors, capturing the data. Finally, this data will be analyzed by intelligent software, which will decisively determine the quality of the meat and the remaining shelf life of the product. Benefits expected from TOXDTECT project. Clear labeling system. Consumers will no longer be confused with best before and consume by dates, since the information they get is provided in real time from the real product they are purchasing. Reduction of food poisoning cases caused by defective packaging or incorrect manipulation in the distribution chain. First, we performed a pre-screening of the volatiles produced in a meat package tray. CITA prepared several meat trays sealed under a modified atmosphere with a piece of meat from 2 cuts, outside and top loin. The trays were monitored during 9 non-consecutive days, where the VOCs produced were identified by solid phase microextraction chromatography, or SPME, and correlated to the bacteria growth of mesophilic aerobic bacteria, molds and yeasts, total enterobacteria, Pseudomonas sp, and Bruchothrix thermosfacta. 3 biomarkers were selected by CITA as indicators of meat spoilage. Next step was to develop the polymeric formulations that will be part of the array sensors and that will be printed and embedded in the multi-layer film of the meat packaging lid. A wide number of formulations were prepared by Inspiralia based on water-dispersible conductive polymers and tested as possible sensors using a gas chamber and potentiostat. When the VOCs enter into contact with the polymer ink deposited on the printed electrodes, the polymer swells, and this swelling produces a change on the current that is registered by the potentiostat. From these tests, the design of the array of electrodes and the 3 formulations, both sensible and selective to each biomarker, were developed by Inspiralia. On the other side, OFI designed a multi-layer film structure with an outer layer of high stiffness to protect the package from the exterior and an inner layer permeable to the VOCs selected with good sealability to the plastic tray and to protect the meat inside of the tray. These 2 layers will be partially laminated with the appropriate adhesive, keeping the part of the sensors free of adhesive. The selection of these 2 films was based on the results from mechanical characterizations, chemical and physical tests, and permeability tests to humidity and VOCs, but also other factors such as cost and industrial production feasibility were also considered. In parallel, we worked in the design and fabrication of the electronic reading device to be connected to the package and on the predictive software. The electronic device fabricated by Inspiralia for the TOXDTECT prototype consists of a plastic box containing a development board LPC2368NXP microcontroller, which offers the possibility of displaying data for user monitoring and the meat shelf life prediction. The reading device is connected to the package by direct contact between the electronic pads printed on the film and accessible in the flap of the lid. After a few seconds of contact, the screen displays the remaining days of shelf life for the packaged meat. Alternatively, the electronic device can be connected by USB or Ethernet to a PC. Innovative packaging for the detection of fresh meat quality and prediction of shelf life. Detailed information about the project can be found at the project website, www.toxdtect.eu.